Okay, so today I'm going to look at an example of a phylogenetic tree, how it's organized, what the components of it are, and to do this I'm going to use different species of dragons. So here's our basic phylogenetic tree. Here we have 9 different species, and these species here are what we refer to as OTUs, or operational taxonomic units. Basically, they're used to categorize organisms based on their genetic similarities. Now for this phylogenetic tree, I organize these different organisms into categories based on their morphology. So there was an initial split between limbed dragons and limbless dragons. And the limbless dragons, they didn't further split down the line, but that doesn't mean they didn't evolve. Through anagenesis, we know that even if a species does not split into separate species, it still changes over time. But in the case of the limb dragons, we had clanogenesis happening. So that means that these species split into different species, which further evolved into completely separate species. So in this case, we had limbed dragons splitting into 4-legged dragons and ones with no legs or 2 legs. The 4 legs then further split into high elevation dragons or low elevation dragons. So this would be an example of a allopatric speciation event where geographic changes lead to different species. So dragons that live in high places and like volcanoes or high elevation mountains wouldn't have mated with low elevation dragons who live in the forests and the deserts. Then we had a speciation event with the no-leg and 2-legged dragons. So we had 2-legged dragons that have wings, wyverns that further split into red and blue wyverns. And then we had serpents that have no legs but are winged, and we have 2 species there, split into feathered serpents or scaled serpents. And for the wyverns and serpents, that could be an example of a sympatric speciation event, where there are no physical deterrents, no geological or environmental deterrents to them mating, but genetic differences could have arisen which discouraged or made mating impossible. Now just to look a bit more at the design of the tree, at the far left we have our root. That's our most recent common ancestor. In this case, landworms are going to be our outgroup, since we're mostly looking at the more dragon-like species with wings. And in the red, we have our internal nodes, and those show every speciation event that occurred. Now the position of the bars and the relative distance between speciation events can give you an idea of how recent a speciation event had occurred.